Good morning.
Morning.
Morning,
Hey,
Mohammed. Would you let me record? I won't forget today.
okay. Yeah, let me give you permission. Okay. So uh, we our number is keeping getting low for some reason, but okay, whatever. So let's remove the inheritance stuff and okay. So yesterday, the last thing we were talking about is the relations between classes, which is actually more of the relations between tables in databases, but we will learn that they are actually the same thing. But like when we work with databases, they call them relational databases for this reason. Anyway, we learned that there are many types of relations between classes. Okay, we said that it's one to one. Okay, like you and your address. Okay, you have one address and the address belongs to one person, which is you. One to many. Okay, like for example, uh, a teacher and a supervisor. So a supervisor has many teachers to supervise, okay? While the teacher has only one supervisor that is like above him. Uh, Customer and order, okay? The customer has or could have many orders, okay? In any shop or any business, any restaurant, whatever. While the order, the thing you order, okay, it belongs to you, okay? Like you want order something and you will see the same order going to different people, okay? Your order only belongs to you, so it's one too many. Now, the one that it's a bit complicated is the many to many relation. So suppose that we're talking about course and student. Okay, so the student has so many courses or could have so many courses, and the course usually has many students. So both of them has a list of the other. Okay, so that's when we call it many to many. So first, let's create a class exam. Let's say, well, let's start by create a class exam. Okay, so please start working. That contains, like when we are talking about an exam, okay, of course, there's something that's very important to mention that in OOB, most of the time there is no single correct design. Like, for example, we are making an OOB design for an institute or a hospital. So there is no like single correct, like this is the only correct design that we could have. Okay, there could be multiple designs and all of them, like some of them are better than the others in some circumstances, some of them has some advantages and some disadvantages in others. So like we don't say usually that this is totally wrong, totally correct. We can say like this design is better in this case, this design is better if you are, for example, an international hospital, but if you are a local hospital, someone else's design could be better. Okay, so it's most of the time is weighing down the advantages and disadvantages of each design. It's not like saying, of course, unless there is like a very big mistake. Okay, like imagine the relation between student and course. So if you made it one to many, it's like you're saying each course has one student. So it doesn't matter what you do after this point, lots of stuff won't make any sense. And this design eventually won't work. Okay. So as long as you stay from those extremely terrible mistakes, okay, everything should be fine. But we will notice and we will take a lot of examples while we are advancing in our program that there are lots of different potential correct designs. So we want to create a class exam. So in the exam, like when I tell you there's an exam, usually you say, okay, what is the course? Okay, that contains a course, okay, um, an institute, okay, like you will say like there were an exam for math in or at MITT. There you need also to know the date, stuff like duration, okay. Can you see my screen? Yeah, you are seeing this one. Okay, duration. What is the passing grade? Like you need to pass 50 or 60 or... And of course, what do we also need? Like when I tell you there's an exam for math, okay, it will be in this date and let's suppose that it happened. So what do you also want? First, what's the relation between an exam and a course?
It has the same name, and the grade of that exam affects the grade of the course.
Yeah, well, it has the same name, like grade for which student? Like how many students could have an exam?
Many. Many to what?
So does it have a grade or a list of grade? Okay, so it has a list of students who took the exam, right? So the relation between exam and course, like, okay, you say a course could, like, this depends on the place. So some courses, for example, like our courses have only one exam, but in other places, the same course could have a list of exams, right? So the relationship between exam and course could be what? Like at MITT, let's suppose like our course. Do you remember our previous course? We had one exam, right? And we won't have a course where we have more than one exam. Okay. And of course, an exam, like, do you remember the previous exam we did? Does it belong to many courses or to a single course? So what's the relation between exam and course in our case at MITT now?
1 to 1.
1 to 1. Okay. An exam for one course. A course has one exam. Okay. That's how we do it. Okay. What if we said in university at U of M, usually for the same course, they have a midterm exam, then they have a final exam. Okay. And sometimes they have those surprise exams. So what is the relation now in their case?
1 to many.
So now, of course, the exam is still for one course. Okay, so it doesn't matter like when I am going to write an exam, I know that this exam I'm writing is for a certain course. I know that I'm not writing an exam for like 10 courses at the same time. Now, there could be maybe that some kind of, those kind of exams that people do usually when they are studying to be doctors. There's one exam that covers everything. That could be like a special case, and maybe that could be like a different class at all. But um, the key to know the relations is to understand the business itself. So before you create, for example, a system for MITT or for a hospital, you need to understand what they do. Okay, like what do you do here at like on daily basis? Like how do you distribute work? Like, okay, how do your students interact with the teachers? You need to understand the business, okay, before you write the OOP design. Okay, and understanding the business is like sometimes is longer than writing the system, the actual code. Like they send people to meet with managers or workers. They start writing notes, and and then of course you need to keep meeting with the clients and show them. We will talk about when we talk about the agile methodology, but understanding the business itself is like a key feature in understanding how to write a proper design. Okay, because you can't assume stuff. You can't say, yeah, okay, exam and course is 1-to-1. What if they have more than one exam for a course? Okay, you can't assume the business logic yourself. Anyway, this is all just like general thoughts. Okay, and let's say a list of students who took the exam. Okay, so please write down this class. Okay, nothing special in it, just writing a class. So I don't want you to keep looking. Okay, so let's start doing. And while you're working, what's the relation between exam and student? Like as a student, how many exams could you have?
As many as the course the student takes.
Yeah, well, let's not like mix all the relations together. Let's just take about exam and course. Sorry, exam and student. Okay, so as a student, can you have like one exam only or a list of exams? Okay, you can have a list of exams as a student. Okay, what about the exam itself? Is the exam for one student? Like, does the exam inside it have one student or a list of students? Okay, a list of students. So it's many to many. Okay, so we can agree on that. Let's write down the class.
Mohammed,
Yeah,
can a class have more than one parent?
no.
Okay.
Yeah, in C Sharp, multiple inheritance isn't allowed. In C++, for example, multiple inheritance is allowed. Okay, but most modern languages, C Sharp, Java, they saw that it's very complicated. Yeah, sorry, I should have mentioned that yesterday. So they saw that it will make things extremely complicated when you have multiple inheritance. Okay, like when you are inheriting from multiple classes. So they said that's like we want allowed. Okay, when we talk about interfaces, we will see that you can implement or inherit from multiple interfaces. and we will see like a walk around for that. Okay, let's write it together. So said we want the class exam. Okay, so in the exam, you need first to know for which course this exam is being created. Okay, we also need to know in which institute. We said we want date. Okay. Let's call it date. Like how many minutes, maybe we can say like, okay, minutes duration. Okay, so like some exams are 90 minutes, some are 120. We also want to know the passing grade. Okay, like this one is 50 or 60 or... So grades are usually, when we talk about grades, this can be integer, that's fine, but we usually like, because some people can have like 70 point something. Okay, so the grades are fine to be double as well. Okay, and of course the list of students, okay, who are taking or who took the exam already. Okay, or the students who are supposed to take the exam. Okay, so this is our design for the class exam. Okay, and what we care about here is the relationship between exam and students. So we said like when you have something from a class in you, then you should have like the opposite thing. Okay, so in the student, okay, so the student has a list of courses, and the student, like maybe a student took a course and didn't take an exam. So we can't assume that every time you take a course, like we don't really want to make a big mix of them. So let's treat exam and course as like different entities. So the student has a list of exams, okay, that this student took. Yeah, okay. It's better, of course, not to initialize it here, but we're doing it just since we are just starting. It's better to leave the initialization for the constructor. Okay, so the student has a list of exams and the exam has a list of students. So it's a many-to-many relationship. course. Okay. Now, the thing is, if you only want to know what are the exams for a student and who are the students for an exam, this is enough. Now, the problem is most of the time you want to know extra stuff. So let's suppose that I want to register the grades. Okay, like you as a student, you like I know you have an exam because you have a list of exams. Okay, like you are a student. Okay, let's just close those. Yeah, this system is getting big actually. Okay, so you are a student. I know that you have a list of exams. Okay, that's fine. So where can I register the grade? So like I want to register your grade for each exam. So can I have here something like called
Can you make it dictionaries?
public? Yeah, let's try like our first thought. Like okay, you will say okay, the grade, okay, in the student. Okay, if you said something like that, grade. Okay, so this is a single grade, right? So where are you going to like for or which exam you're talking about here? Like I have a list of exams and you are telling me I will have a grade. So for what exam is this? So this won't work for sure.
Maybe store in the course.
Okay, course. Okay, so if I said grade, if I said here like one grade won't be enough. Okay, even if you did a list of grade, let's say okay, we have a list of grades, but what if you want to also register other things? For example, when it comes to exams, what if you want to know if a student is like or has cheated or not? Like sometimes you want to register the grade and also you want to register like who cheat. Like I have 3 or 4 students, this is their grade, but I want to mark them as cheaters in this exam because I caught them cheating. Okay, like I want to keep this information, so like in the future when they ask why did I fail, I will tell them, oh, you are marked as cheater. Okay, so the standard is when you have a many to many relationship and you want to register extra information about this relationship, okay, that's when you create a third class for the many to many relation. So when it comes to exam and student, okay, now if I just want to register the list, I only want to know who are the students for exam, and in the student I also want to know the who are or what are the exams for a student. If this is all what I want to know, the names, that's enough. But most of the time I want extra stuff, like the relationship between student and exam. I want to know the grade. I want to know if this student like cheated or not, if this student came like came late, so I can remove like 20% of his total mark. Okay, so I want to know, or I want to register lots of information regarding the relationship between student and exam, which is a many to many relationship. And that's when I create a third class. So usually the third class that we create, okay, we call it like the name of the third class, we call it like using the names of the 2 classes that are having the relation. So we call it student exam, for example. So the first word is from the first class. The second word is the name of the second class, because those are the classes that are having the relation. So here you can register what? You can register like any extra, any extra information regarding the relation between student and exam. Okay, so here where I register the information regarding the student and exam. So for example, when it comes to student and exam, what do you want to know? The most important thing. The grade, right? Like, well, what is the grade? So you can say something like public double grade. Okay. Now, the relationship between student and exam, I also want to know, for example, like even before the grade, like, sorry, here I'm saying extra information, but what are the non-extra? What are the essential things? When I talk about student exam, the first thing I need to know in this class, okay, like this is a grade, right? So a grade belongs to who? To a student. Okay, so in this class, I want an instance of student. Okay, like who is the student I'm talking about here? Like you want to register the grade, right? Okay, so you want to know like who is the student you are talking about. Okay, and is it enough to know just the student?
The course.
You also want to know what is the exam we are talking about here. Okay, exam. Okay, so what is the exam we're talking about here? Okay, now those are the main things. Okay, and now I register any extra things like grade, like for example, Boolean, cheated. Okay, like I want to register who cheated in the exam. Public, also a Boolean, late, like were you late? For example, in the rules, for example, if you came late, we want like we will allow you to enter the exam, but we will remove like 10%, 20%. So we need to know who was late and who wasn't. Okay, so the many-to-many relationships are easier to work with because they follow a standard. So the standard is create a third class, okay, and name it. Of course, the name is your choice. You can name it whatever you want, but so you know in the future, like, oh, this was to break the relation, the many-to-many. Okay, so what you do is in this third table or in this third class, okay, you will have an instance or a piece of each one of the classes that they have a relation. So the relation was between student and exam, right? So in this third class, you will have a piece of student and a piece of exam. Okay, an instance from here and instance from here. Then register any extra information you have. Okay, so we will have another example now, but just take a look at it and try to memorize the rule. The rule is, okay, I have a many-to-many relationship between student and exam. Okay, now if I want to register extra stuff, this won't work. Okay, I need a third class. So in this third class, okay, I will have an instance from both of them, from each one of those two classes having the relation, and then register any extra stuff that concern this relation. Okay, and that's how it goes. Okay, now the last change I need to make is what we're doing here is called breaking the relation. So the many-to-many relation needs to be broken and needs to be converted to one-to-many. Okay, so what I want to do now after you create the third class, okay, there is no longer a many-to-many relation between exam and student. So see this list in the student or in the exam, sorry. This one, instead of a list of students, it will become a list of this third class that we made. Okay. And now this exam has a one-to-many relationship with this class. Why? Because the exam has a list of the third class, and the third class has one piece of exam. So now it's like, what's the relation between those two classes? Look at this. This one has a list of this third class. Like notice the list here. It's from this type. Okay. And this type, this third class has one exam. So now it's one-to-many. We broke the relation of many-to-many to one-to-many. Okay. Same goes for students. So students now, they are no longer connected to exams right away. They are connected to the third class that we created. So here's the student. Okay, this is a list of exams. Okay, now it's no longer a list of exams. It's a list of that third class that we created, student exam. Now you can keep the old name, that's fine. It's just a name. But what's important is now student is connected to that third class. Of course, do you remember when we had a dictionary of grades and stuff? Like, okay, like this one is no longer needed. Now we can represent the grades in a modern OB way with our student exam. Okay, so many-to-many relationship includes a lot of steps to break the many-to-many relationship. Okay, so what should we do? We should create a third class. In this third class, you have a piece of each. Jennifer, are you looking at your screen? See you looking down. Okay. So in the third class, we have a piece or an instance of both of the classes we are trying to break the relation between. Okay. And then after we create this, and after we add any extra things we want to add, now we go back to the original classes and we change the lists. Okay. And now the lists, instead of having a direct relation, they are both connected to the third class. Okay.
I have a question on line
Yep.
193, the list of students there.
Okay. Line 3.
And 193, the above, the list of student exam.
Okay.
Why would it have a new list student exam at the end and the other lists too?
Well, this is the rule that it was a list of it was a list of students before, right? That's what, like we said, an exam has a list of students.
No, I mean like
Okay.
when we do get set, don't we do like new list and
Okay, yeah, it was new list. Okay, so that's how it was. Okay, it was a list, but we broke the relation between exam and student, right? We
Yeah,
said
that-
we created, yeah. So that's when we change this one to student exam. Okay. Yeah, of course you will initialize it like somewhere, like either here or in the constructor. Or it's better to be the constructor. Okay. Yeah, let me try. Sure if I can do it. So, like before, we had like this is student. Okay, this is the class student, and this. Okay, and then we have the class what exam. Can we So you can't edit. This program is dumb. Okay. So before we had a many to many relationship. Okay, like it was something like, or let's try this one. Okay, that's how was the relation. So we said many to many. Okay, we need to break the relation. So we need to create a third class. Okay, that we call student exam. Okay, usually using like the name of both classes. Okay, and now instead of those two, okay, now those two are no longer connected to each other right away. Like now in student, there's no longer a list of exams. And in the exam, there's no longer a list of students. We just remove it, okay? Okay, we remove it. And now instead of connecting them and having lists of each other right away, we connect them to the new class, the new third class. Yeah. Well, I'm terrible in drawing in real life, in computers, in any shape or form. Okay, but it's just to explain. Okay, so after you create this third class, okay, you need to make sure that in the student there's no longer a list of the exam, and in the exam there's no longer a list. Both of them, okay, both of them have lists of what? Of that third exam, third class. Sorry. Now let's take a look at our code. Exam has a list of what? Of that third class. Okay, and student has a list of also the third class. Both are connected to the third class. We literally broke the relation between those two. Okay, and replaced it with a one-to-many relation with a new class. And now it goes very easy to represent the grades, to say like, now student exam represents like each student in a certain exam. So for example, in the main now, when you say something like, just keep the shape. Okay, when you say something like student exam, like std exam equals new student exam. Okay, so now it's like I am in the system entering a grade for Sulay. Okay, so it's like what like this is new is like me opening Sulay's profile, saying, okay, I'm entering a grade for this student for this exam. Okay, because this is a student exam object. Okay, so I will say std exam dot student. Okay, so here I will say that it's, for example, like some or a student. Okay, you will say like, who is the student? Like Sulay, for example. Okay, now I don't have Sulay, so I need to create his profile, but I'm imagining that I already have his profile created. Okay, then you will say something like, then you will say std exam dot exam. So when I'm in his profile trying to enter the grade, of course I need to select like what exam from a drop-down list or something from the exams that he did. Okay, and here like an exam that the previous student took. Okay, and then start recording the grade. So std exam dot grade equals, for example, 80. Then std exam, like this student, okay, this student in this exam did he cheated equals false, and like std exam dot late, for example, was true. So I need, for example, now to do some kind of punishments or remove a certain grade, or okay. So what's going on here, just imagine yourself opening the system as a teacher. So I have a list of students. Okay, I clicked on Saria, for example. Okay, I clicked the name, so I chose the student. Then the system will ask me, okay, choose the exam. I will choose the exam from a drop-down list, and then okay, enter the grade. Did this student cheated? Of course, it's Saria, so yes. Was she late? Yeah, well, she is always on time, but she cheats. Okay, so see, so that's how you need to imagine. Always imagine that you are the person who is using the system, okay, and like the teacher to enter the grade. That's what the teacher needs. Okay, the teacher needs to see a student from a drop-down list, or maybe search for the ID of the student. A teacher needs to know the exam. Then, okay, enter the grade, enter like cheating status, late status, enter anything. Okay, and that's exactly how I represented the relationship between student and exam. Now, the student, as Soleil, for example, he will have a list of those, right? A list of the whole thing. In your profile, you will have a list of, okay, what exam, what grade, what did you cheat, and the exam as well. The exam, like math exam, will have a list of those. Okay, student number one, that's his grade. That's okay. So you will notice, like very soon, that although we followed some rules here, like okay, create the third class, but this is actually what happens in real life as well. Okay, it's exactly how we represent it.
Do we
Okay.
break every many-to-many relation or just case by case?
Well, most of the time, yeah, you need to break them unless you don't need to register any extra information. Like if that's only what you need, an instance from this and an instance from this, then the third class is not necessary. Then you can keep the list in exam from student and the list in student from exam. But if you need to register any extra information regarding this relation, that's when you need that third class for sure. Okay, so it's a good practice to always create a third class. It won't hurt, because maybe at a later point you will need it, and it will be much easier to add a single property or single field rather than adding a new class, changing everything. Okay, so every time you have a many-to-many relationship, create a third class. That won't harm. Actually, it's good. Okay. Okay. Okay, let's take a quick break, and then we'll take another example about many-to-many relationships. Now, this whole thing will be repeated in our um, database class, but we work with tables at that time and with databases rather than classes. Then we will create code from our database, and you will see that when Visual Studio will generate a code for you, that's what it will do. It will see, oh, there's a many-to-many relationship between those two tables. Let me create a third class for them. Okay. Now, if this example is understood only 50%, that's fine. Okay. The next example, another 50%, and hopefully it will be totally fine. Okay. Yeah. See you in 15 minutes. Okay, we're back. Okay, so let's create another class. Okay, so create a class department. So the department, you know, for example, at MIT, we have the Department of IT, the Department of, I know, art. Okay, and in the art, you have lots of courses. Let's say that, for example, some courses like Introduction to Programming, okay, could be part of the Department of IT, and also, for example, the people who work in civil engineering, they also require some introduction to programming. So create a class department, and also so, for example, when we talk about the relation between department and course, okay, so a course could belong to or could be in many departments, okay, like math course. So we are IT students, we study math. You have also the students who study like physics and chemistry. I'm not sure what they call that department. Art, like science department, maybe. They also have also the math course. Okay, and of course, a department can have many courses. So there is a many-to-many relationship, and we need to register extra things. Okay, so we need to know if a course is mandatory for a department. Okay, like this is the first extra information we want to know. Like, for example, math and the Department of IT. So math is not a mandatory, it's, for example, an optional course in the IT, but it's mandatory in the Department of Math, okay, or Department of Science, okay. What else do you think between course and department? Okay, let's think if you know if you have any extra information. But for now, we want, for example, to know, is it optional or mandatory? So we want to create the class department. We already have the class course, so don't create it, obviously. But we want to represent the many-to-many relationship with a third class and register the extra information to know if a course is mandatory for this department. Okay? Okay, let's try to make it ourselves. So start by creating a class department. Department has a name, okay? Has maybe like just a name should be fine, okay? But what we care about is the many-to-many relation here. Okay, so let's do it together. Okay, so after exam, student exam. So let's create our class department. Okay. Okay, so we said in this class, just put anything that's that may describe a department. So like you have usually an ID. That's what we will see later. For now, we have a name. Okay, and maybe let's say maybe who's the supervisor. So like who is the admin? Okay, for this department. Okay, we don't really care about the admin now. It's just to add something. Now, what we care about is the relationship between department and course. So we said in the department, okay, we have a list of courses. Okay, now with new or without the new, it's not a big issue now. Okay, so we have those courses. Now, we said if the department has a list of courses and it's many too many, so in the course, okay, you should have, in the course, you should have a list of departments that this course belongs to. Okay, so let's have, let's say, okay, list of departments, okay. Okay, because it's many too many. Okay, so that's how we start. Now, we said we need extra information. Now, once we need to register extra information regarding the relationship between department and class and course, okay, and the relationship is actually many to many, so that's when we need a third class. Okay, so many to many, we need extra information. Okay, let's create the third class. So the third class, we can call it department course. Okay, this is the third class to break the many to many relationship between department and course. What should we have here? An instance from this and instance from this. So one instance from department. Okay, what is the department? And one instance from course. Okay, the other side of the relation. Okay, so now that's when you will register the extra information that we're talking about. Okay, so that's when we say, for example, what did we say, the extra information? Yeah, if it's mandatory. Okay, okay, this one. So here, like I'm talking about department and course, okay? That's when I say, okay, Boolean is mandatory. Okay, so when I say, okay, the course math in the department IT is not mandatory. That's how we describe the course introduction to programming in the department IT is mandatory. The course introduction to history in the department of science is not mandatory. And that's how now we represent the relation. What is the last step after creating the third class? Okay, what should we do? Remove the relation between the original two classes and make it a relation with the third new class. Okay, so now, okay, let's go back. The department has a list of courses, right? We want to break this relation. So now instead of list of courses, it's a list of what?
Department.
Department course, the third class that we just introduced. Okay, What about courses? Courses had a list of departments. Now it has a list of what? Of course, of department course. The third class that we made. And what is the relation between like the original classes and the new class now? Look at them. This one has a list of the new class, and the new class has one piece of it. So what is the relation?
One
One.
to many.
One to many. So we broke the relation from many to many to two relations. Okay, two relations of one from many to many to two relations of one to many. Okay. Now we'll do it over and over. We will do it also when we talk about databases. Okay. But it's very important because now every time we want to create a design, you will always see like, oh, should I put a list here or something here? So if you don't understand the relations between classes and how we build them, it will always be confusing how to present them. And it's also like an introduction to databases. So when we talk about storing and about tables, you will notice that it's almost the same story there as well. Okay.
That's very interesting. I never saw this concept in program, only in database.
Yeah, but tomorrow when we will make the database, okay, we will work with Entity Framework, which is an ORM. Okay, so from the database we will generate our code.
Oh,
Okay.
I got it.
So
and then
the generated code will look like this.
oh yeah, because I in program language like C in Java or C Sharp, that's my first time that I see this kind of thing. What is the name of the concept ORNG? That you said that we generate from the database the code
ORM.
or
ORM, you mean?
ORM, yeah.
Yeah, ORM, Object Relational Mapping. So tomorrow when we will work with Object Relational Mappings, okay, we will just design the database and then we will ask the ORM to generate the code for us, okay? Or we will do the opposite. We will write the code and we will tell the ORM to create the database for us. So it's you do one task, okay? So you either write the code and the database will be generated for you. So that's what we call code first. Or you build the database inside the database system like SQL Server, okay? And ask the ORM to create the code for you. And the code will look just like this. Okay? And like how would you represent the relation between, like, even forget about databases. If you want to talk about grades, eventually the grade class will look just like this. Now call it student exam, call it grade, whatever. To know a grade, okay, what is a grade? A grade is just a number, okay, but a number about what? About a student in an exam, okay, and it's a value, okay, it's like 80, 70 about a student in an exam, right? So you will see yourself creating something similar to this even without noticing, even if you are not caring about databases. And also, like, okay, a student took an exam, okay, maybe you want to register like extra stuff. Okay, well, you want to know if this student was late. Where are you going to put this thing? Next to the grade. Okay, so this is not like a special thing that we do only if we want to store, but it's just the logical way of thinking. Okay, now everything here is just like a representation of real life systems. Okay, but most of modern systems, they use ORMs. Okay, so it's just like an introduction to when we will use ORMs, when we will create databases, and you will see when we will generate the code, like, or when we will ask the engine to generate the code for us, okay, it will look just like this. Okay.
I still
And
am
then
not
we
really
will call
clear.
those navigation properties. Yeah. Sorry.
I'm still not really clear on the highlighted part that you just made. When is it not mandatory to say get set equals new list department course?
Well, it's mandatory. Like eventually you will put stuff in this list, right?
Yeah.
Okay. So when you want to put list stuff in this list, it will be null. So it needs to be nude somewhere now in the right away or in the constructor or somewhere else. Like this is a list which is null right now. Like look at this
Oh,
list.
you say new something in the constructor.
Constructor here, outside,
Oh, doesn't matter.
wherever
Okay.
you want. Okay, but
Okay.
you will see that the most common way to do it is in the constructor. But like it needs to be nude somewhere. It doesn't really matter that it's not that big critical deal where is the new, but there should be a new. Otherwise, once you try to put anything, it will complain that it's null and you will have null reference exception. Okay, and the whole thing will stop. Okay. So okay. Now the thing is, some of you like they know programming before. I know the hardest thing honestly about creating the curriculum is to go gradually, like go step by step without telling you the whole story. Now you will notice that sometimes we will learn something. I will say, okay, but this is not the correct thing, or this is not the final shape of the best solution. But it's very hard to show you like the end result of like the top-notch design. Okay. Going step by step honestly was the hardest part when I was writing the curriculum, like how to introduce things slowly and how to make them make sense without confusing you very much. So like maybe you know programming before, like we had some students who had the degrees in programming. So sometimes like they will think like, oh, but this is like maybe not totally correct, or there's a better way. The thing is we are just trying to move slowly in order to absorb everything. So there are many ways to reach the end point. Like you can go in many directions. You can go faster, you can go slower. Eventually, we will get to the same point, but it really depends on like how we want to get there. Okay, I prefer the slow, and maybe first we like it's important to know the bad designs in order to distinguish them from good design. Like I can from the day one show you like, okay, this is the best thing, this is the best design. But it's really important to know like when we had this bad design, I had this problem. So in the future you will be able to distinguish the good designs from bad designs. Once you see something, you'll see, oh, but this is going to create a problem in the future. I tried this before and it didn't go well, or it was limited. So it's like seeing some of the wrong ways while we are on the way. Is actually a very good thing. Okay, you will be able to distinguish them from the correct ways in the future. Yeah, just a simple note. Okay, let's start with classes now, and this is just an introduction. So we will talk about them over and over. Okay, so don't worry about that. Now, when it comes to lists and dictionaries and everything, so notice that, do you remember when we said, okay, a list can contain virtually anything, like either integers, either like strings, or even classes that you created. So what makes the list able to host anything? Okay, let's go to the definition of the list. See the list, okay? So you will notice that, okay, is it a list of integers or a list of strings or department? you will notice that it's called T. So T is like a general way or a general term to describe a type. Okay, so it's from the word type. That means like the list needs a type to host. Okay, that's why it's now all of those are just interfaces. You can just ignore them now. Like it's something similar, like those are not classes. Okay, in case like you are telling me, okay, it's inheriting from different classes. Those are not classes. Everything that starts with I, just a naming convention, everything that starts with I in C# is most likely to be an interface, which is something totally different than a class. Okay, and you can have so many interfaces. Okay, so the list can host any type. Okay, and that's what we call generic types. Okay, let's create something similar. Let's first see like why it's important to have something like lists. So let's create our own. Sorry.
For that last part that you were showing us, it looked like it was inheriting, like it has iList as its parent, and then all those other ones behind it. Is that not?
No, those are interfaces, not classes. So inheriting from one class, for more than one class, the inheritance we saw is prohibited. Okay, you can't inherit from more than one class. Those are not classes. Okay, like iList. If you went to iList now, it's an interface. It's not a class.
Oh, okay.
Okay. Now we didn't study interfaces yet, but they are not classes. They are a different thing. Okay. So you can implement, okay, any number of interfaces you want. That's fine. But if there's a class between those guys, now everything starts with I. That's interface. But if there's a class, that would be the only class that you can have. Okay.
Okay.
Okay. Now, we don't really want to go extremely deep when it comes to generic types, okay? But generic types, they were invented or introduced into C#. I think maybe C# 2 or 3. I don't really remember, but I remember they were there since I started learning C#. They were introduced to solve some problems when it comes to dealing with types, and also for code reusability. Like, first thing you will notice that the list, okay, can work with anything. Like, imagine they have a list for integers, and they also created a list for like another list class for strings, and then another list class for booleans. Like, it will be endless, and you can't really stop. Like, and of course if you want to use it with the types that you created, that won't be possible. Okay, so they said, okay, why not create it to work with any type, okay, and call it the generic types. Okay, let's create our own generic type. So it's not very common. Sorry, yeah.
Sorry, this is the same of generic in Java. Or similar.
Probably, yeah. Yeah, I guess so. Yeah. Sorry, it's been like 7-8 years since I worked with Java, so sometimes I just don't want to answer if it's not totally correct.
Okay.
Yeah, but Java and C# are extremely similar. Okay, so suppose that you want to create a class, okay, that will work with any type. Okay, so let's say, for example, I want to create a class called my generic collection or my generic array. Okay, you know, arrays are not generic, so when you like work with arrays, they are old-fashioned. They don't work just like generic. So I want to create my own generic collection, and I want to create my own functions. Okay, so you will say, okay, this class, okay, will take a type T. Just like the list, for example, do you remember the list? it takes an integer, the list takes strings, okay? So it will take a type, regardless of what is this type, okay? Now, you can do whatever you want here. Like if you look at the list, if you went to the list definition, you will notice that you have like functions, some functions that return integers. You have some functions that return t. So when you want like the function find, for example, okay, see the function find? The function find in a list is supposed to find what? An item in the list, okay, and return it, okay? So what is the type that the function find is going to return? Is it going to return an integer or a string or a department? What's the thing that the function find is supposed to return to you? It's supposed to return from the same type as the list. Okay, so if the list is departments, then it will return what? A department when it finds it. Okay, if the list is from courses and you are using the function find, so it will return what? If a course, right? So the type of this function, of the return of this function depends on what? The type of the list itself. Okay, so I know it looks a bit confusing, like what is this? Okay, but it's really important just to take as like, I don't think we will use generics very much, but every once in a while you will see, oh, this is a generic type. Okay, and of course list and hash set and dictionaries are like the most common examples for them. So I just want to introduce them to you. So when you see something like this, like you won't get totally confused, like what is T? Okay, so T is a type, and sometimes, for example, let's see an easy one. Okay, contains. See, contains is nice. So contains will return what? A Boolean, right? Like it's either there or not there. So it's a Boolean. But what is the input or the parameter of the contains? Like when you are in a list of students and you will say, okay, does this list contains Willie? So what is the type of the thing you are passing to see if it's in the list or not?
Is any?
Student.
Yeah, it's the same. It's the same type of what are the contents in the list. Okay, so if it's a list of strings, you will say, okay, does it contain the word hello? So here you passed what? You passed a word. You passed a string because the list itself is from a string type. Okay, and that's how like you will see some T's here. Like what about T array? Like this is copy to, like, you know, we really never use this function, but this function is supposed to copy. Okay, so you will pass an array of the type of the list itself. Okay, and that's it. Now you may ask, okay, what the problem is we didn't study objects yet. Okay, that's fine, but let's create some stuff here. Like let's suppose that I have in my collection, okay, I care about, like for example, I care about a specific number or sorry, a specific member. Okay, I will call it the main item. Okay, so I'm creating my special collection, which I needed for my work for some reason. Okay, and I want to create something called the main item in my list. So, you know, arrays, they have first item, last item. I want to like choose one item and decide that this is the main item of the array for some reason. So what is the type of the main item? It's an item inside my collection. So is it an integer? Is it a string? Is it a course? it really depends on what I'm going to put in the first place in my collection. Okay, so imagine like you know the list. Okay, I'm creating a similar class to list, but with my own conditions, with my own like needs. Okay, so I have something called main item. Maybe I have something called second main item, which is also from type T. Like in my collection, I have two items that are like very important for me. Okay. Let's say, for example, I also have like the list. So in my collection, it's a list, but with extra stuff like main item, second main item. So I also can have a list inside my my special, let's call it or let's call it items or all items. Okay. For example, I can create a function that gets any item. So this function will return an item, get item. Okay. Just tell me what is the index you want, and I will return the item for you. Return all items index. Okay, of course, those are useless functions, but I just want to show you the code and the syntax of Generics. Okay, like we don't want to create a complicated example along with complicated code. Okay, so here it's just like a way to see how the syntax looks like. For example, I want a function to set the main item. So this one takes an input of type T. Okay, so this dot main item equals the new main item. Okay, so what I'm doing here is I'm creating a class, okay, for any purpose, but I'm not saying what I want to put inside this class. I want to make it generic for any type, to host any type. So now, for example, I can create, for example, so this is my generic collection. Okay, now I want to create my generic collection of integers. Okay, so now instead of T, now it's an integer. So what is the type of the main item in my collection? It's an integer, right? Because the list itself or the collection itself is integer. Okay, so there's nothing like very hard or anything. It's not like a puzzle or anything, but it's just so a new way of seeing the code. So for example, my generic collection dot all items. Oh, those need to be public, I guess. Okay. My generic collection dot all items equals, so all items is a list, right? Inside my special collection. It's a new list. So let's say like 6, 9, 1, 0, 3, 5. So those are all the items in my special collection. And I want to say, for example, my generic collection dot set the main item. So the main item, I want it to be 0. That's the main item for some reason. Or suppose, what if this list was of type student? So now I can use my own generic collection, okay, I can use it with students. I can put students in it. And now I can have something called main student and second main student. Depending depending on the conditions or the properties that I have. Like there's no other, like you don't have any other collection that has like main item, second main item, least important item. You know, there's nothing like this in programming, right? So maybe you want to invent it. Maybe it's important to you, like, okay, in a list of students, I need to know who is the main student, for example. So what should you do? That's when you create your own generic example, your own generic collection. Okay, now the usage, I know it's terrible, but this is the simplest example I thought of. Okay, my generic collection 1 equals new. Yeah. So you can now decide what are the students in this collection, who is the main item or main member of this collection. What we care about here is that we are able to create a type that can deal with any generic type. Just like how they created the list, and now you can use list with anything. What about dictionaries? Like, let's create a dictionary. So in dictionary, let's say int as student. So like number 1 is this student, number 2 is this student. Okay, a dictionary. Let's call it my class. Okay, our class here. New dictionary. Okay, what about dictionary? Let's go to dictionary. So dictionaries, they need what? They need 2 types actually. So let's go to dictionary. So you will notice that dictionaries, they have 2 things. They have type of the key, type of the value. But the same dictionary works for anything. Integer student, integer string, string integer string. Okay, anything. They wrote it one time, and now it's able to work with everything. Okay, so why do we need this? First, it's called reusability. Okay, you are reusing the same type for everything. Now, in addition to code reusability, you have other reasons. For example, safety. So now, for example, the dictionary that has from integer to student, okay, for sure you can't have a string here or some other like some other type that may cause exceptions for you. So now your code is safe because your code will be able to know what you are supposed to work with. Like this dictionary works with integers and students. Okay, so you know for sure that you won't find a course here, like someone will insert a course by mistake. Okay, if it's generic, if it's not like if it's like you can put anything, okay, then someone may by mistake insert a course instead of a student. And now once you try to see the grades of this course, oh, that's an exception, like courses doesn't have grade. Okay, so it's more safe to work like this because during compile time, during the time you are writing the code, you will be able to notice what are the types, and you won't fall in any problems because someone by mistake inserted the wrong thing. Okay, the types are defined once you create the dictionary or the hash set or the list. Okay, it's also faster because it's faster and the performance is better because when your compiler, okay, and your runtime actually, when your runtime it like knows the type, it doesn't have to guess or see what is the type. So that operation, we call it boxing and unboxing. So for example, imagine this dictionary, or let's go to list. Actually, list is much easier. Imagine this list was okay list that you can put anything. So now what C# has to do, like every time C# takes an item from this list, it needs to see, okay, what type is this? Every time, every item. Okay, is this an integer? Is this a string? Okay, it should unbox it. Okay, it should take the item, unbox it, and see, oh, this is an integer. Okay, that's fine. No exception here. But if you are trying, if it unboxed and it saw that it's a string, oh, an exception. So first, it takes time for your runtime to know what is the type. If this was like not defined, okay, if this was only a list without this t, for your runtime, every time it sees an item, it needs to know, okay, what type of an item is this? But when you decide the type right away, like when you say, for example, list of department course, then your runtime doesn't need to unbox and see the type because it already knows that the type is this. The type is integer for sure. The type is string. Your runtime no longer needs to unbox it and look at the type. Okay, it's called boxing and unboxing, which takes time. Okay, and it hurts your performance. So using GenRX, you will define the type right away. So it's safer. You won't get into trouble. No one will be able to put anything for you and mess up with your code. It's faster because now the runtime knows the type right away. It doesn't have to guess what is the type or look, okay, what is the type of this item. Now it knows that when it's going to look at this list, everything is from this type for sure. Okay, because you defined it this way. So, like what I want you to learn here is just how to read the codes of GenRX. So when you go to the list, okay, when you go to the list and see something like T, TK, T value, to know what is this. If you ever needed to write a generic class that deals with lots of different things, like you want to invent your own collection, your own dictionary, your own hasset, okay, or you want to invent your own class for any reason, and you want to be able to put different types in it, then you can think GenRX. You can reuse the code. It's safer. It's faster. Okay, and that's it. Yeah, like I just wanted to introduce it to you. It's not something like really that takes a lot of practice or we want to go any deeper. Okay, of course, if you want to go deeper, that's fine. Like you can read on yourself and you can understand the whole idea behind them and how they made them, everything. Okay, but for the purpose of our course, this is not what we care about. Okay, so any question about GenRX in general, why they are faster? Like, and a common interview question is, what is boxing and unboxing? Why GenRX are faster? Why they are safer? Like, can't we just say list without that T and put anything in it? Okay, like we can, right? Okay, we can, but now you are in danger that people will put in the same list, they will put courses, students, integers, they will put anything. Now your runtime is taking all the responsibility for guessing the type for each item one by one, which is taking time. Okay, and of course, it's just like less efficient. Okay, after the break, we will talk about config files. We also want to just have an introduction.
Sorry.
Yep.
This is less efficiency, but it's more secure for because those algorithms are tested.
No, I mean less efficient if it's not like this. Like this is more efficient. Like the generics are more efficient than non-generics.
Oh, I got it.
Yeah, so it's more like less efficient. I was talking about the other way.
Okay, okay.
So generics are faster, are more efficient, are reusable, are safer. Okay. You
Okay,
have
yeah.
some other types in C#. I think maybe array list, where you can just put anything. Okay, which is not a good idea.
Well,
You should
because
always.
array list is in Java. This we don't.
I
Oh,
think
we don't have array list in here in C#. I think.
array. No, they have
Really?
array list. Yeah,
Oh, nice.
but array list equals. So you can create an array list here. Okay. Yeah, and of course, yeah, I remember it in Java as well. Okay, so it's better to use the array list which is generic than the array list which is not generic. The array list that has a T. Okay. Okay.
Mohammed,
Yeah.
will you be posting our exam marks? They're not on cam yet.
Sorry?
They weren't on cam when I checked.
Yeah, no, yeah, I didn't post them yet.
Okay.
But I will soon.
Okay, thank you.
Okay. But you saw like you were able to see the assignments, right?
Yep.
In the LMS. Okay. Yeah. Well, that's the major thing. Like some exams I didn't even grade the last time. Like we said, okay, this is an exam just for the sake of having an exam. Okay. And when everything did terrible, we said, okay, let's
But
not record.
Okay. But it's worth 15% of our mark, right?
Yeah, but you already passed, right?
Yeah, but
Yeah. So why do you care?
because
We pass.
okay.
Yeah, look, like I will grade them, of course. I will post them, but honestly, the only thing you need to care about in our program is did you pass or not? Like,
Okay,
this is like
I do want to see like where like more in depth about where I struggle and stuff, and the exam was different than the
yeah, that's true. But like in terms of being concerned about the grade, yeah, that's like
Sure.
yeah, the feedback is important, but the grade itself, I don't want you to be concerned about it. Okay. Of course, unless you failed, that's a different story. That's when you need to be concerned.
I still don't know where the cam.
It's called CANS. Like
it's
I
my
don't.
student.
It's in our student portal.
Yeah, my student portal.
I forgot everything about. Okay, thank you.
Okay. Well, this is the official the official system where we post the grades and we have everything. Okay, the LMS is just for learning. Like that's the CANS is the administration thing. So I think you should have an account on it.
I already sent the link by Slack.
Oh, okay. Yeah, it's on my.mitt.ca. Yeah. But I'm not sure if you can create your own account. They should give you the account and the password as well. Okay, so
all of us got like 100% in the exam.
what? No, I don't think so. Well, the exam was like it's supposed to be like more strict than the assignment, but it's not really a big deal. Like I always have an estimation. Like I take a big look, see if there are very like obvious mistakes, like big issues, okay, and just estimate the grade, which of course everyone, that's what we do in programming. Okay, you don't go like line by line. This is correct. This is not correct. Okay, but hopefully they will be done by today. Okay, it's just like between preparing and between like having everything for the next day ready, it's more important than having the grades ready. Okay, now let's check a few exercises on like our system is getting bigger now. So let's have okay. So now it's time for the most important thing in the institute. which is this one. Okay. So we want to write a function to calculate the GPA of a student. Now, each course has a cost for students. That's something we need to add for courses. We need to calculate the cost of calculate the cost of all student courses. Okay. If he or she has a previous GPA above 3.5, they get a 20% discount. Okay, so now do you remember the course has like how much does it cost to teach it? Now the course itself also have the cost for students. Like the course math has like $1,500 or whatever. Okay, now for a student, I want to calculate, okay, the total tuition for a student. Okay, all the courses. Now, if your previous GPA is more than 3.5, you get a 20% discount. Of course, this is just fantasy, like this is not in real life, but like you get 0% discount. But let's suppose that is this way. Okay, so first in the course, we need to add how much a course costs for a student. Then the student, we need to calculate the cost. Like we need a function to calculate the whole tuition. Okay, but you need to note that if the GPA of a student, okay, is more than 3.5, they get a discount. Okay, so let's work on that. So to know the GPA of a student, of course, you need a function to calculate the GPA of a student. Now you can decide what is the GPA. I'm not concerned about the inner details. Like you can say it's the average grade, okay, of all his courses. That's fine. Okay. What we care about for now is just creating another function to calculate the whole tuition cost and to give a discount for students who are like getting good GPAs. Okay, let's start doing that.
Do that using generic collections?
No.
Oh, okay.
It's we are just adding to like generics is just like something just want to show it to you. So hopefully in the future when you see it, you won't have like, you know, a heart attack or what is this? I don't know. Fall down. Okay. So just to save your life in the future. Like generics are actually just like everything else. They just instead of integer, you have that t, and everything is the same. Yeah, like it's really not anything different. Okay. Yeah, this is for some gender equality stuff, you know. So you don't say why he, like why are supposing he's a male? Okay, he or she. Okay, I don't want to get accused of anything. Calculated as 0. Okay, and if you are late, your total grade I will take only, like for your GPA, I will only take like 80% of it. It won't be calculated for you. Like your GPA needs to suffer because you were late. So of course, like those rules are not very important. This is not a real system, but you need to be careful. Like when you are doing your job, when you are writing the function to calculate something, you know all the rules of the place. Okay, all the rules of the institute, or all the rules of the hospital, all the rules of the government you are making the system for. Okay, so that's what we call the business logic. So here some business logic regarding GPA calculation. Okay, so it's just like ask them. Okay, they will tell you that's what we want, and you just need to reflect it in code. So if the examiner cheated, total equals okay, so if it's not cheated, then we need to another if actually. So if not exam dot late, so if you didn't cheat and you are not late, then what should we do? Okay, the total is like the whole grade. Otherwise, if you didn't cheat but you were late, so the total should be what? Exam dot grade, but this time it's like you will get only 80% of the grade. So students lose 20% of their grade if they were late to the exam. Okay, so I only calculated 0.8, which is like 80%. Okay, so like this is some logic I am trying to satisfy according to what they told me. Okay, but of course, like in real life, it's way more complicated than that. Now, what should you return? Return the total divided by the number of exams that this user or this student had. Okay, so just like a regular average. Okay, we don't want to create it between 0 or 4 or something. It's just like the average grade of your exams is your GPA in this institute. Another institute, they say, no, we want a scale from 0 to 4. Other places, they will say, no, we want a scale from 0 to 8, 0 to 10. Okay, it's not really very necessary. We are just learning the whole design thing. Okay, now, of course, like, or convert it to a scale from 0 to 4 or 0 to 8, 0 to 10. Okay, I hope that you get the idea here. So some business logic regarding are you a cheater, are you late, then calculating the average. Okay, and now the institute, like the administrator who works with Class Institute, in their dashboard, they will select a student from a drop-down list. They will click a button called Get GPA, and this operation will be invoked, and then eventually they will see the final GPA for this student. Okay? Is there any question regarding what we did here? And see how easy it was to access all the exams of the student. So in the student itself, you have a list of exams. And what do you have in the exam? You have the grade, right? You have, did he cheat? Was he late? You have all the information you want for a single exam for a single student. Okay, so for example, Soleil did an exam of the first course. Okay, now everything he did regarding just this course is stored in an object of what? Of student exam, the third class that we created. Okay, I hope that is clear. If it's not, please try to repeat it home. See if you have any question.
Sorry.
Yeah.
Is it if it's better to store an average GPA to a student class? Because
Yeah, well, that's also, for example, an idea. So if GPA is something that students always need to access, and you don't want to waste a lot of processing power all the time, then maybe you can have another another field which is called like latest GPA or current GPA or whatever, and always store it in the student. If it's not up to date, you will call this function. But if it's up to date, then you just read it from the database, from the GPA field. You don't need to recalculate it every time over and over. Okay. Now, if it's simple calculation, that's fine. But sometimes imagine like you are calculating something that requires 2 minutes of calculation power. That's too much. Okay. And you have thousands of students or thousands of customers. So in this case, it's very important to store it. Okay. And if it's up to date, just return it. If it's not up to date, calculate it again and store the up to date value. So is it clear what Sule is asking? Sule is asking why we don't store the GPA in the student. Yeah, that's good. But eventually you need this function at least to calculate it for the first time. And you also need this function. So every time a student advances in a year, you will do this recalculation again. Okay. So storing it in the student is a totally good idea. Now, this is the get GPA for a student. Now, public double.
Is the
Now,
This depend the calculate the GPA for a student. It can be calculated in real times or storage. But if you have a data that this data need to have you need to have to use different field for calculate the data, is good idea to calculate in real time because you don't want to use all the storage for storage the calculate data.
yeah, it's like it's always a balance. So you either sacrifice processing power or
Yeah.
storage space or storage power.
But
So it depends. Like if this is something you calculate once a year, yeah, that's fine. Maybe you don't need a place. But imagine like I want to come and see this field every 5 minutes. Like I'm obsessed with my GPA for some reason. So every time a student will come and see it over and over, So you really need to know what is the average like what is the average need for something. If it's something that requires lots of processing power and people need to see it all the time, then it's better to store the up-to-date value and
Yeah.
sacrifice, like it's just a number. It and storage is is cheap. But if it's something that you calculate every year and people don't come back to see it every time, and you don't want really to waste storage, now it's fine to just have it in real time, as you said. So
Yeah.
it's always about what you have.
Another thing is how many times change the data in the time.
Yeah.
That's mean in this case, I know that the GPA change almost like
But once a year,
2 times
maybe.
per year, more or less.
Yeah.
But it's fine if you storage it.
Yeah. So
But
what
if
Willie
the
is
data
saying,
change,
yeah,
yeah,
what Willie
it's
is
okay.
saying, for example, if we are talking about weather, maybe, or something, or not weather, something that changed every few minutes, so we need to recalculate it anyway. So he's saying, okay, it's better maybe to not store it. But even in this case, maybe Willie, you want to store the last calculated field if you are interested to know what was the last, and maybe compare it. Like
Yeah,
now
that's right.
people now are storing everything. You know, like in Facebook or Twitter, they store your old password. Like even when you change it, like what do you want to do with the old password?
No,
Like
but the
it's
old password is okay because this is a security issue that you need to know the last password because you don't want to that the user use the previous one because
no
this is
like not only the last one, all the last ones,
all
like
the last one.
all the last ones.
Not all, but most of the last five of them because
Yeah.
we have
Well,
some
you
standard
don't
in this
change a
case.
password every day. Yeah, but I mean, like even sometimes when it feels like it's not very necessary, like what do I want with something that the user changed years ago? Or sometimes when you delete something, when you delete an image, they don't delete it. They keep it there, but they tell you it's deleted. That's why you sometimes, in some cases, you can restore them because they are not deleted in the first place. So storing shouldn't be very scary. We like it's okay to store stuff, and eventually, when you have like big data, for example, you are saying if it's real time and lots of calculations. So imagine what if I want to study the change in the value over the year, and I want to see the trend, for example, for the GPAs for this value. So if you are not storing every value, now you can't make, for example, a study, or you can make like some deep knowledge about how it was changed over the years, for example. So like some people store everything because eventually they can, there's a science called big data where they analyze everything. Like, when you go and browse a website, they store every click you do, every every stop you do, because they know, oh, he liked this ad, so maybe we need to show it to this user again. Now you notice when you stop on something on Twitter or Facebook, they learn about you, or like you like this fashion ad more than you like this sport ad, so they know that you love fashion. They store everything you do. So let's not be so like afraid of storing stuff. Okay. So we need to get um, tuition for student. Okay. So also to know the tuition for a student, you need to select who is the student you are calculating the tuition for. Okay. So the thing we said we need to add, like in the course itself, we have the hourly rate, like cost to teach the course. Okay. Of course, like later we will learn that commenting on stuff is a bad idea. Like your variable should really tell what is the purpose of this variable. You shouldn't write something that is ambiguous and then explain it in a comment. This is very bad. Okay. The best thing you can do is to describe yourself totally in the variable name or in the function name right away. Okay, don't write some ambiguous name and then try to describe it in a comment. Here, cost for, let's say, cost for students. Okay, so it can't get any more obvious than that. Okay, so what is the cost for a student in this course? Okay, $1,000, $2,000, whatever. So how do you calculate the tuition for a student? Okay, again, I have a total, which is double. Okay, so for each course in, I'm writing a paragraph. In this student dot, do you have a list of courses in the student? Yep, so it's very easy to access it now. So for each course for this student, the list of courses, okay, what should you have here? You should have total plus equals total dot the cost. Sorry, not total. Course. Okay, in the course you have cost for students, right? In the course itself. But we said we have a condition that you don't always calculate the whole cost. If the student is a good one, we will need a discount for this student. So before I calculate the discount, I need to know the current GPA for the student. So how do you know the current GPA? We just created a function for that. So call this function. Of course, don't repeat the code. Okay, just call the function that gives you the GPA, right? And what does this function need to work? It needs a student. So what should I pass here? The same student I'm calculating the tuition for. Okay, pass it to the GPA calculation. Okay, so the same student that you were calculating the GPA for will be, the tuition will be used to calculate the GPA. Okay, so before I add the total amount, if current GPA is bigger than 3.5, okay, yeah, I think we need to remove this to 0 from, or maybe I can change the question. So the previous GPA should be more than 80. Okay, it really depends on the place you are working on. So if the current GPA is more than 80, okay, it's just a number. Okay, don't get confused here. So what should you do? Should you calculate the whole total amount, or the total equals the course GPA multiplied by 0.8? So this 20% discount. Okay. Otherwise, like you don't get any discount. So otherwise, the total will be just the whole amount. Well, I think we can do something better. Why am I calculating the GPA for each course? Yeah, you know what? I guess we did
outside.
We could put the outside after for each, maybe.
Yeah, I guess this would be like, well, it's the same result, but it will make more sense. So first I calculate the whole total, okay, without any discount. Now after I could calculate the whole total, okay, now I check if the current GPA is 80 or above, then the total will be discounted by 80%. Otherwise, you don't need to do anything. The total will remain the same. So you don't even need the else here, right? So if you didn't calculate the discount, then the total will remain the same. Now just return the total. Okay, I think it's more clean this way.
In 249, it might be total equals total plus.
Oh, so wow, that's well, that people will pay a lot of money now. Sorry, I
equal-
copy pasted the code.
Yeah, equals total plus 1.
Yeah.
And
Actually, now, not GPA, sorry. Oh, well, I'm really getting tired here. Yeah, is this correct?
yeah,
Yeah, sorry. I'm not sure why I had the current GPA there. Okay, yeah, sorry for that. So actually, people who were good now will, in my previous code, they will pay double the tuition. So it's good that's really fixed it for us. Okay, so it's terrible to be good in this place.
Mm.
Okay, so it's like it's all about just like working with relations and classes. We don't really care about the inner details. Okay, but all what we want to do is to see how easy now it's to work with everything. Like in the student, you can access the courses, then you can access the exams, you can calculate the GPA, you can do whatever you want. Okay, and this code will be identical to the code that we will work on when we study ORMs and databases. So it's just a heads up to that time. Okay. Okay. Now, please try to do the same thing. Like try to at least read the design and see if it makes sense. Now you can find alternative designs. That's fine. But that's one of the good ones. There are many good ones for any system. Okay. It's not only one that's accepted. Tomorrow, when we'll have an assignment or exam, you will see that your design is different than someone else's. But there should be no big logical mistakes in them. Otherwise, like it will be extremely hard to work with that system. Okay. Okay.
When you said tomorrow, you mean in the future, right? I'm like,
yeah.
assignment and exam tomorrow. I'm like, what?
No, there's no assignment and exam tomorrow. It's after tomorrow. Okay, so last thing we want to see today is look at this number, max credits allowed. So imagine that now I'm going to give this program to someone. I will give them the EXE, right? So the EXE, you can find it in the, if you want to bin debug. Okay, so this is the EXE. Okay, so I will give the EXE for people and they will work with it, okay, which is cool. But what if they said, oh, sorry, instead of 15, we want 10. So what should you do now? You need to open your Visual Studio again, change 15 to 10, make another EXE and send it again to them. And this is a very lengthy process because those EXEs or websites or whatever, they are very hard to recompile and publish. It may take a week. Okay, you can't just put another copy. Okay, so sometimes those small changes, like if the user is asking for another class or another feature, yeah, sure, there's no way but to open the code and add the new feature. But if the user is asking for some number to be changed, for example, if the student failed 5 courses, they failed the year. This is the rule. What if tomorrow they change their mind? They said, okay, we will allow 6 courses. So it's not something that should require you to recalculate, to recompile everything and send another exe, and they need to open it, install it instead of just to change a simple number. That's why we have the config files. So the config files are usually used for lots of configuration, including those small configuration stuff. So you will have, like, this configuration is written in a language called XML. I'm not sure if you saw XML in front end, but XML is a markup language. It can virtually represent anything. So you have a tag called configuration, or an element called configuration. Inside it, you can have another one called app settings. So inside app settings, now you can define keys and use them in your code. So you can say, for example, of course, you can add. So the key is what is the name of this value? So like max credits allowed. And the value is, let's say we said 15. Okay. You can add another key. So this is just a text file. So the person, you will give them the exe. You will also give them this file, which is just a text file. Okay. The key is uh, what keys we can have as well.
Duration of code.
Well, no, duration of course is different for each course. So it's bad to put it here. Now, if all courses have the same duration, yeah, that's fine. But do you remember in the course, we have a duration for each one. So you can't write like unlimited durations here. Let's say max courses or number of failed courses to fail the year. Okay. And here the value is like 5. You can fail like 5 courses, or that's too much actually. Say 3. Okay. So now I will use them inside my code. Okay. And I can set them up. So one thing we need to notice that those app settings, they won't work with const. So const needs a number. So if you need them and you don't want them to be changed later, what is the like something that looks like const but it's not const, and it allows you to set the value later? So something similar to const.
Read only.
Yeah. So do you remember we said we have const and read only? Const needs a value right away. Read only will allow you to set the value later. So you can set the value of anything later if it's read only. But sometimes it doesn't need to be const or read only. It could be like just a regular thing. So in your program, let's say institute. So the institute, okay. So this is our institute. So we have a name of institute. We have a list of courses, list of students. We also have like an integer, okay, failed courses to fail the year. Okay, so let's like initialize it to 5. Or you don't need to initialize it, just keep it there. So for example, I want to initialize it when I create the institute, okay, but using the value from here. Okay. So, and that's when you can use the configuration. So for example, let's say that I created an institute. Let's call it MITT equals new institute. Okay. Now MITT, it has a list of students, list of courses. Okay, that's fine. And it also has failed courses to fail the year. So this field, I know that MITT are so annoying. Every day they will come, oh, can you make it 6? Can you make it 5? So instead of saying, okay, it's always 5 and keep it always like this, and now if they want to change it, they will come back to me, hey, can you open your Visual Studio and make a new copy where it's 4? Or a month later, they'll say, oh, okay, can you please make it 3 now? Every time they will come back to you just to change a single number, a single value. And that's when you decide, okay, what about if I used, what was that configuration manager? So they had a way, then they changed it. Use system.configuration. Yeah, system.configuration. So dot app settings dot get. Okay, what is the key? So here you need the key that you have. So this specifies. So this is a dictionary eventually. Can you notice that? Like key value, key value. Okay, but it's a dictionary, of course, in text, just text, which is XML. Okay, so I will say, okay, this MITT.filled courses, okay, is no longer a hard-coded value because I know those guys are extremely anxious about the number and they change it every day. And of course, this is what is the return of the get. Look at the get. What's the return of the get?
String.
It's a string, and you are trying to put it in what? In an integer. So what should you do?
Int
Just convert it to an integer. Okay, with int.parse. Okay, just like what we did all the time. Okay. So now it doesn't matter how many. Let's try to write it. Console.writeLine MITT dot failed courses to fail a year. Okay, just to make sure that it's correct. So let's start this program. Okay, so how many failed courses you are allowed before you fail year 3? Why? Like where? Like I don't have 3 here. I just have some app setting thing. So it took it from here. Okay, what if you came here and changed it to 9? Okay, this is a very like nice space. They allow the courses. Okay, and now it's 9. Okay, you will say, okay, you still have to come back to Visual Studio to change it, right? No. So when you go and give the exe to people, you will give them the exe and you will give them this config file, which is nothing but a text file. Okay, so imagine I am MITT and you are the programmer who gave me those. Like, hey, this is your system. You can start the exe, but then, oh, I need to change the number of failed courses. So what should I do? Without coming back to you, I can open this config file. Okay, I can edit it in any text editor. Okay, by the way, this is a very nice editor called Notepad++. It's like Notepad, but like in 21st century. Okay, so this is just any editor. Word, Notepad, Notepad++. So now MITT decided, oh, we need to fail people the whole year if they failed a single course, which is the actual case now. Okay, okay, they need just to save it. Okay, let's close it and let's open our exe again. And now what is the number is 1. So you were able to like save maybe months of work just by using some configuration. So everything that's need to be configured and the user can control it. And you know, like, of course, there are some stuff like the value of pi, 3.14. This is not a configuration. This is something that won't change. Okay, that's not something you put in a configuration. But number of courses to fail, max credits allowed, max max number of international students in the whole institute. Okay, like for example, the government changes this number every year. Okay, what should you do? So of course, there are so many things that you can save in a database, but there are some stuff as well that you can also save in config files. Now, using databases, and the user goes to a database and change the number through like an interface, of course, is much better than using config files. But when we learn about databases, we will see that there are stuff that are way better to be put in config files than in databases. Okay. So this is the idea of config files. And of course, when we work with database, we will see that the connection to the database is something that you definitely store in a config file. The version of .NET, you know, we are working with .NET framework. So there's 4.5, there's 4, the version of entity framework. So configuration at this time is mostly for programmers to configure their program. Okay, but you can also have lots of values that are very easy to put here, like to open this file and change a value is much easier than opening a database and changing a value. So you will notice that, yeah, for some values is very suitable to put them here. Okay, now regardless of the usage, we just want first to know that something like this exists, and when you changes when you change this one, you don't need to recompile your code. And you don't even need Visual Studio. You can close the whole Visual Studio now and just go to the exe and change to this config file. Okay? This is like the most important thing, that you don't need to go back to the code to change this value. Okay? It's used to configure stuff, okay? Either for the programmer himself or for the user. And it's very easily done and accessible. Okay, and that's what we say config file. Every time you create this C# project, any C# project, okay, you will see that, oh, there's always app.config here. Okay, and of course there are so many different things. Like we saw app settings, there is startup. Like maybe sometimes you want to do stuff when you start up your program. You can have assembly bindings, config builders, connection strings. Those are for databases. Entity frameworks, also database stuff. Runtime, satellite. What? I have no idea what is that. Satellite assemblies. Yeah, this looks scary. Okay, anyways, there are like lots of stuff to do, and what we care about is mostly the app settings and the connection strings. Okay, and they are stored in config files. Okay, we will learn more about XML, but for now XML is something somehow similar to HTML, but of course for a different purpose. But look, it looks even the same, like tags and open the tags, close the tag. Okay. Okay. So a big part of our program is to know stuff. Okay. Like to know that there is something called generics. Okay. This is a small introduction of it. To go in more detail, to be like a professional in it, it's your job. Otherwise, we will spend the whole program with the first 2 courses. Okay. So my job is to put you in, like to put your first step on the road. Your job is to continue. Okay. And I can guarantee that we will cover most of the important things that will make you comfortable working in any environment, in any workspace. But there's a big chunk of work that you need to do yourself. Okay. So it's an enough start, but it's not enough overall thing. Okay. The overall stuff is up to you. Okay, any question regarding configurations, keys and values, the usage of them inside the code? Okay. So tomorrow we will continue with our example. We will take more requirements, and of course we will study a new thing. Okay. My really advice, again, for the millionth time, is try to study it yourself so you can come tomorrow ready for new things. If you are still stuck here, you can see like in one day we learned 3 different things. Okay. So it requires really a lot of effort. Please try to catch up very soon. Okay. Any other question? Okay. Yeah. Let's take 15 minutes break and get ready for the lab. Okay. See you tomorrow. Bye.